Hi guys, and welcome to this video on simultaneous equations, part of the Year 12 Further Maths course, but relevant for all sorts of years. It doesn't matter whether you're here in Australia or all over the world. My name is Darren, MaffsGuru, and it is my pleasure to be here delivering maths in hopefully an easy to understand and slightly humorous way. Yep, I'm on YouTube. If you can do me the favour and head over there and subscribe, I'd be deeply, deeply grateful. Never going to be rich and I'm never going to be famous, but for every person who subscribes, I just know that someone is watching, and that actually means the world to me. There is also MaffsGuru.com, where all these videos are there. They're linked to textbooks, they are sortable, they are searchable, and they have downloadable notes. And so head over there. It's absolutely free to sign up. Learning objectives. We need to know what simultaneous equations are. Now, yes, you may have been dealing with these in previous years and gone, oh, yuck, I remember that elimination and substitution stuff and it didn't make any sense to me and I don't know what I'm doing, and had some full-on mental breakdown. Well, hopefully not. I'll do the mental breakdowning for all of us. But we need to be able to, for this particular lesson, know how to solve simultaneous equations. I'm going to show you how to do it by elimination and substitution, but at the very end of the video, I'm going to actually break it down and show you how to do it using a CAS calculator first. And more importantly, I'm going to show you why you're doing it and what it is you're actually doing when you solve simultaneous equations. Now, in previous lessons, we've been dealing with straight lines, and we know that we can have equations of straight lines, for example, of y equals 3x plus 2. We know in that situation that that would have a gradient of 3, so we would have a gradient of 3, and we would have a y-axis intercept of 2. Right? Why is it important to me? Because I can now know that I'm going 3 up for 1 across, or rather 3 up for 1 across, 3 up for 1 across, and I know that I've got a coordinate or a start point on my line of 2, which is my y-axis intercept. I've also got the idea of sort of 3x plus 4y equals 12, and that's called intercept form. Why was that important to me? Because it allowed us to find the intercepts. We could find an x-axis intercept, I could find a y-axis intercept, draw a straight line between the two, and job is done. But so far, all that we've dealt with is just been one straight line. But obviously, graphs don't necessarily just have one straight line. They can be a number of straight lines added together, or they can be graphs that cross. And yes, this is exactly what simultaneous equations are. Believe it or not, simultaneous equations are just two straight lines. Here is a straight line, and here is another straight line. All right, so this is my y-axis, and this is my x-axis, and there are two straight lines. Now, if we are really lucky, those straight lines are going to cross in one place. And the whole point of simultaneous equations was to find where those two lines cross. Now, obviously, if we have parallel lines, they are never going to cross, and that's an important thing to remember for this particular course. And believe it or not, there is another example where the two lines they give you could in fact be exactly the same line, in which case they have an infinite number of crossing points. But again, that comes in a completely different part of the course, and it's massive in Mathematical Methods Units 3 and 4. So, in Year 10, we showed you two ways of doing it, really confusing. If you're lucky, you had a CAS calculator and you were shown how to do it, or you were told graphically, because there are probably 4 ways that I know how to solve it, maybe 5 if I'm being really, really funky. So let's start easy and get harder as we go through. So let's show you how to use your CAS. So the first thing I'm going to be doing is solving the equations 2x minus y equals 4 and x plus 2y equals minus 3. Now again, there are two equations there, two completely different straight lines. They're written in intercept form because for some reason with simultaneous equations we find it easier to do it that way. Not necessarily the easiest way, but it's a way of doing it. So what I'm going to do is going to look at each equation individually. So let's look at the first equation. 2x minus y equals 4. Now the shame of it is that for the TI Inspire, you can actually enter that in and you can sketch it and life is good. But for the Casio ClassPad, you can't, you have to rearrange it. So the first thing I'm going to do is I'm going to just show you that I've got 2x minus y equals 4. I'm going to take the y over here and I'm going to bring the 4 back there, because basically I'm going to add y to both sides and take away 4 at the same time, which gives me that 2x minus 4 is equal to y, or y is equal to 2x minus 4. Now actually you can get your CAS to do that for you by solving, but again, a whole new discussion and probably outside the scope of this particular video. Don't worry about it. So there we go. We got the equation 2x minus 4, and when I put it into my CAS and sketch it, out comes that funky graph below. And let's just check. Look, there's my y-axis intercept at minus 4. There's my y-axis intercept at minus 4. Does it have a gradient of 2? Well, hopefully if I go 2 up and 1 across, I get to a point. 2 up and 1 across, I get to a point. And so that's a nice visual check to allow me to do that. So there we go. There's my first line. Likewise, my second line, I've got x plus 2y is equal to negative 3. I don't know why the 2 didn't do there. Take away x from both sides gives me 2y is minus x minus 3. And then divide both sides by 2 to give me minus a half of x minus 3 on 2. Now again, slightly outside the scope of this video, there are videos on my channel about algebra and about how to do all of this in detail, so maybe head over and watch some of those. But I'm only doing this because a class pad can't deal with it in the other way. So there we go, there's my equation, and what do I notice? Yup, I have an intercept of minus 3 on 2, or minus 1.5, and a gradient of minus a half. Let's just check that. For every 1 I go down, do I go 2 across? Yep. For every 1 I go down, do I go 2 across? I absolutely do. So there are my 2 lines. When I draw them together on the same set of axes, what do I notice? Oh, as I said a moment ago, they cross. Here, in fact, is where they cross. You can see that. And when we solve simultaneous equations, then we are just finding that crossing point. How do I do this? Well, there's lots of ways of doing it. I actually can bring up my, my calculator can do it for me. So I can hit Analysis, G-Solve, and then Intersection. Because when I'm looking for an intersection, what is that? That's just a point where they cross. Yeah, that's what an intersection is. And what you'll notice is it comes up with a coordinate value here, but it also comes up with it here. Sometimes I think it's a bit, look, I mean, if you see this, what a stupid place to put the coordinates. It's actually crossing through that line. You know, you have to have really good eyesight to be able to see that. But also what they're saying is your x value is 1 and your y value is minus 2. So 1 comma minus 2. So they cross at the point 1 comma minus 2. Why is that important to you? Well, in a later video, we do something called break-even analysis, which actually looks at profits and running businesses and all that really funky stuff that I'm sure lots of people are going to need in real life. But the point of simultaneous equations is to find where lines cross. There is another way of doing it using your CAS, and that's through using what we call a system of equations. And you will notice on your CAS calculator, there is this button here. That's if you've got the Casio. If you've got the TI Inspire, I'm sure it's there somewhere. I used to love the TI Inspire, but the Casio ClassPad is all the way for me. So what you do is you hit that button once and up comes this funky little thing here. Now, worrying not a jot about those open brackets or that open bracket there, we have 2 boxes, a line and another little box. Now, the reason we have 2 boxes is in this box here, we're going to type one equation, and in that box there, we're going to put another equation. And there we go. That's exactly what I've just done. So what you can see now is, and the good news is you don't have to rearrange it. Thank you, Casio, for one thing. So in this situation, the first equation, 2x minus y equals 4. There's 2x minus y equals 4. My second equation is x plus 2y equals minus 3, and we're done. So the question is, what do I put in that little box there? Well, it's all well and good putting in equations, but you've got to tell the calculator what values you're asking it to try and solve for. It's not that clever, all right? So what we're trying to say is, well, what are our pronumerals that we don't know? What are the values we're trying to find? And as it turns out, we're looking for the values of x and y. And so that's exactly what you put. You put x, comma, y. Now, you can do this with 3 equations, 4 equations, as many equations as you need to, just as long as you tell the calculator what your pronumerals are that you're looking for. And lo and behold, when I hit the enter key, what comes out? Oh my goodness gracious me, x equals 1 and y equals minus 2. So again, if I wanted to, I could write that as a coordinate as 1 comma minus 2. But ultimately, what I'm doing is I'm finding where these things cross. Now, obviously, there is a harder way, and this is the type of stuff you were shown way, way, way back when, but substitution. Now, when you substitute, you take one letter and replace it for something else. So in this situation, I've got 2x minus y is equal to 4, and I have x plus 2y is equal to minus 3. Now, what I'm going to do is I'm going to rearrange this. I'm going to take away 2y from both sides to give me x is equal to minus 2y minus 3. Why is that useful to me? Well, because I'm now going to substitute this into this equation here. So where I see an x, I'm going to replace it with minus 2y minus 3. Now, why am I putting it in brackets? Because I'm taking one letter and replacing it with more than one, and I need to make sure I've got that. Minus y is equal to 4. Multiply out this bracket gives me minus 4y minus 6 minus y is equal to 4. And so what I'm now going to do is add 6 to both sides. That gives me minus 4y minus y is 10. I've got minus 5y is equal to 10. Divide both sides by minus 5 gives me 10. Divided by minus 5 gives me that y is equal to negative 2. Now that I know that value there, how do I use it? Well, if you remember, I substitute it into one of the equations. And the chances are I'm going to substitute it into the easiest equation there, which is 2x minus y is equal to 4. So 2x, I know that minus y is minus 2 is equal to 4. So 2x plus 2 is equal to 4. Take away 2 from both sides gives me 2. And so x is equal to 1. And ka-ching, thank you very much. There we go. All right, so that was substitution. Can be easy in some cases, can be a lot harder. And then there was elimination, which was that random way we did before. So just to go through elimination, we've got 2x minus y is equal to 4. And x plus 2y is equal to minus 3. Now in elimination, we have to make sure that the constants in front of either the x or the y are the same, or the numbers in front, the coefficients are the same. So what I'm going to do is I'm going to multiply my bottom equation by 2, which gives me 2x minus y equals 4. Is this all bringing back horror and nightmares? Me too. Multiply the bottom equation becomes 2x plus 4y is equal to minus 6. Now, because these two here are the same, I'm going to subtract them. Reason being, because a plus and a plus means I subtract them. So minus y minus 4y gives me minus 5y. And 4 minus minus 6 gives me 10. And so y is equal to negative 2. And lo and behold, having got that, I go back and 2x minus y equals 4. 2x minus minus 2 is equal to 4. 2x plus 2 is equal to 4. Take away 2 from both sides. Gives me 2. And so, in fact, x is equal to 1. Now, there are hundreds of thousands of billions of millions of these type of questions you could do. But trust me, the more practice you get, the better. But otherwise, just use your CADs. You've got 2 ways to do it. Graphs or just your system of equations. And there we go. That's the end of this video. Thank you very much for watching. It has been good to see you. If you haven't already done so, can you subscribe to my YouTube channel? Again, it just helps me to know that you're watching. And head over to MaffsGuru.com, sign up, and you can get downloadable notes and searchable videos and exam questions as well. I'm done. Thank you very much for watching. Hopefully you are well and staying safe, and I look forward to seeing you in another video. Take care. Bye-bye.